All right, let's get going. Good morning, everyone. I'm Pablo. I work in the Foundry IQ team. And what we'll do in this session is talk about what it takes to connect agents and your AI models with the knowledge that makes them connect to your applications, to your company, and to the data they need to get their job done. So, cutting to the chase, Foundry IQ is the thing you use to connect agents to knowledge. Now, when we think about Foundry IQ, we think about getting this done with three fundamental elements in consideration. First, we want it to be a piece of cake to get started. Second, we want versatility so that as your application gets sophisticated, your needs grow, or the problems get hard, you have what you need right in the same platform. And third, like any AI-based system, you want top quality across the entire set of components that are AI-powered. In particular, for retrieval, you want great ranking, great relevance, great content understanding. So that's what we are aiming for. So before we go into the details, we said we want it to be easy to get started. So let's actually test that out first. So I'm here in Foundry, and we'll go back and forth between a few different developer surface areas, so you can get a flavor of all of them. But I'm going to start in Foundry. So I'm going to go to Build. I have a Foundry project already created, and what I'll do is I'll go to Knowledge. Oh, I'm sorry, this is very small. Hopefully that's a little better. So this is the part of Foundry where you manage all your knowledge bases. So what I'll do is I'll create a new knowledge base, and we said easy. So let's just take an easy case where we just have a bunch of files, and we want to make it the way you would do it in a chat application today, where you can drag and drop some files and ask some questions. If you want to build your own version of that, it's kind of the same thing. You can now just say, hey, my data is just in files. And I'm going to give this kind of knowledge source a name. I have a few files about movies, so I'm going to call it Movies Wiki, because I took them from Wikipedia. And I'm going to describe what this does so the agents know. So I'll say use for, or rather, we'll say full articles about movies. Yeah, so there are microphones in the back, but yeah, I'll speak up, and I think folks turned it up. Thank you. All right, so what I'll do is I'm going to grab some files. I'm going to just drop them here. These are kind of just movies, like articles for movies I took from Wikipedia. And I'm going to go hit save on this. So now I have like a knowledge base. And this knowledge base, I'm going to grab the name. This knowledge base lives in a particular Foundry IQ instance I already created. It's called here demo 3. So if I want to use it, I could go call APIs to go consume this, or out of the box, every one of these knowledge bases is an MCP server that I don't have to really do anything to kind of stand up or run. So because I'm being a little lazy, instead of writing a new agent, I'm going to use GitHub Copilot as my agent. So here I'm in just a new GitHub Copilot session. What I'll do is I'll say MCP to see what I have configured. I'm going to add a new MCP server. I'll call it Wikipedia, if I can type. So what I'll do is I'm going to use an auth proxy to connect the dots between these two things. And I'll say, I'm going to point it to my new MCP server. In this case, demo 3 was the name of my Foundry IQ instance. So I'll say that. I'm going to say .search.windows.net because this is backed by Azure Search. I'm going to say knowledge bases. And I'm going to paste the knowledge base we just created. And this is the entry point to your API. But if you want an MCP server, you just say /MCP, and you're done. You have an MCP server right there. And like all of our APIs, they have an API version. In this case, this is the API we shipped today. So I'm going to hit save on that. And now I have just a new MCP server connected here that is backed by the data I just uploaded a second ago. Like if we go here and take a quick look, you'll see that all the files I uploaded before are like now ready. They are processed and ready to go. So once I have this, if it works, let's see. Let's give it one more shot. Let's see if it still does it. All right, let's try it one more time, and if not, I'll just use one that I already have. Okay, now it's gone. Let's do it again. So we said MCP auth proxy. We said demo3 was the name of our service. Search.windows.net. Knowledge bases, and then the name of our knowledge base, MCP, API version, and brand new API version. All right, so we'll give this a second and see if it goes. But the idea is, once I have this, then I can ask questions about this knowledge base, if network and everything kind of helps us. So I know some of the movies there, so I'm going to say which pill did Neo take? So now what this will do is, to answer my question, it wants to ground on the MCP servers that we have. So it'll go try the knowledge base I created. It'll send a few questions, get kind of grounding information, and then it'll say Neo took the red pill, and kind of this came from the matrix. So it took a minute to just go from 0 to a working knowledge base that I can connect from my agent using MCP or using an API. Now, of course, like this is a super simplified scenario, but we said we wanted to make it easy to get started and then be able to continue from there. So the way we built Foundry IQ is to be a comprehensive system that is layered in a way that doesn't hide options from you. You just choose to use whatever layer you want. At the top, we have the Foundry integration layer, where you just saw how quickly and how productive you can be in building new agents. In the middle, we have a complete knowledge retrieval system that uses agentic retrieval when needed, and it'll handle things like iterative query planning. It handles multiple sources and chooses when to query what, and it connects to the entire Microsoft IQ surface. And it has APIs that you can use directly to connect from there. And in turn, that is built on this foundation of our code retrieval engine. Think of this as a state-of-the-art system that will do vector retrieval, it'll do lexical search, it'll combine the two, it has state-of-the-art ranking models, all the things you need to get the best quality results during ranking without having to rebuild all of this from scratch, and in the backdrop of enterprise-grade security, quality, and scale. Now, when you use Foundry IQ, I just did a quick pass, but if you look into the process in detail, usually what you do is you start by provisioning a new Foundry IQ instance, then you create a knowledge base like I just did, you add some knowledge sources, and then you retrieve. So let's walk through this process and talk about how are we improving each of these stages to make it easier and to be able to enable you to do more things with it. When it comes to provisioning, so far, Foundry IQ and the underlying Azure AI search technology has required you to create what we call dedicated capacity. Dedicated capacity is great when you have a steady workload because it's very predictable, it's isolated to your environment, and you control exactly what happens in there in terms of competing workloads. On the flip side, you have to know how much capacity you need, all of that, and we want to make this a little easier. So I'm excited to announce the public preview of the serverless version of Foundry IQ. With serverless, there is no friction to start. It takes 10, 20 seconds to create a service. The service doesn't cost anything until you actually use it. And when you're not using it, the service scales to 0, and you only pay for the storage that your indexes use. Serverless Foundry IQ is production ready. You can use it for developer workloads, but you can also use it for these very dynamic workloads, like, for example, agents creating services, or cases where your application may need to create and delete services on the fly. So you can start experimenting easy, but you can go to production as is. And it's based on the same state-of-the-art technology that powers the existing Foundry IQ stack. So that means state-of-the-art ranking, instant RAG stack ready to go, and a rock-solid foundation, but with all the dynamic characteristics of serverless. So now you have choice. Serverless is great when you want a usage-based plan. Dedicated is great when you want a highly predictable plan. And when you look at the application patterns, in general, serverless is great when you have lots of medium and medium-sized or small indexes, great for the developer workflow, great for unit tests where you create and delete things on the spot, and also great for agents when you want to let the agents create services and indexes and whatnot on its own. On the flip side, dedicated gives you isolated capacity, and it even gives you the option to run on confidential computing stacks top to bottom. So to use serverless, you can do it from multiple places. We talked about agents and about people using them. So let's try both. I'm going to start by, I'm going to grab a quick prompt, and I'll show you what it does in a second. I'm going to go here and paste it. And what I'll do is I'll say, so I also have this movie data, like movie titles and whatnot from IMDb. So I'm going to tell my agent, just go look at that file and create a new Foundry IQ service, create an index, and load the first, I don't know, 100 rows from that file or so. So I'm going to let that cook for a minute. And I'm going to show you what it looks like to also use serverless in the other surface areas. If I'm here in Foundry, one of the things I can do is, like I showed you before how I'm using this demo 3 service, I can go and create a new instance or connect to an existing one if I have one already. But in this case, I'll say, create new resource, give it a name, a resource group. I'm going to pick this guy. And if you're in one of the regions that supports serverless, like for example, let's do West Central, not that one. Let's find West Central US. Then you can choose serverless as one of these queues, in addition to all the existing ones, of course. So I'm going to say yes to this, click create, and this will take, again, 10 to 20 seconds, and we'll have a new serverless service created. So, and here's like ready to use to create knowledge bases and whatnot on it. I'm going to switch back to this one because I'll forget later. So this is what it takes to create a serverless service ready to go in Foundry. You'll find the same thing in the Azure portal. And if we look at this, so this is making progress. So we'll let it run a little more, but at the end, we'll see that it'll be done creating everything on its own as well. So we'll come back to this in a second. So once we have a Foundry IQ instance, next thing is we got to get data to it. So we have to create knowledge bases and bring data from knowledge sources. Now, I mentioned knowledge bases a few times, so I want to give you a sense of what it is. So think of a knowledge base as the scope of knowledge, not how we access it. That is inside and hidden from the agent to kind of separate concerns. But it's what is the domain of knowledge and what's the policy for using that information. So for example, you can say how much retrieval effort you want us to take, like should we do a quick thing and come back, or do iterative retrieval. You can give us steering instructions to kind of influence how the model works. You can choose whether you want us to do answer synthesis and whatnot. And then underneath this agentic retrieval stack are all the knowledge sources, where most of them is typical that what we'll do is you point us at where the knowledge is, and we'll create indexes with it. So we'll create vector and lexical indexes and whatnot. But we also support federating out to knowledge sources that we need to access online. And regardless of how they are represented, at runtime, we can choose which knowledge sources to use for any given scenario and then go query those. So now the question is, I just showed you at the beginning just to use a few files to ground data. And sometimes you have an easy scenario for that. And by all means, for easy scenarios, we should do easy things. Now, in practice, data is all over the place. We see sometimes you have loose files, maybe the user gives you, or they're in your desktop. Sometimes the data is in an object store or on the Microsoft IQ platform, or even in other applications. So we offer like a spectrum of options. So in all these cases, you don't have to reinvent all the plumbing to go through these. So first, one of the things you can do is you can use just files. The thing with files is, one of the things we all learned using coding agents is how good coding agents are at local file access. And that works great if you have, I don't know, maybe 50 or 100 files, a few megs worth of content. But I'm surprised how often I'm talking to developers, and they're like, look, I have 1 million PDFs in this blob storage account. What do I do? You can certainly not grab your way through 1 million PDFs. Not if you want to issue 10, 20 queries in a second just to kind of try different angles to get the data. So we have this file knowledge source that what it does is it allows you to just upload content. So it's the same as files, except that it has the whole retrieval engine behind them that creates indexes and does fast retrieval. Not only that, but when you push the files, like I did before, we'll run them through full content processing. So we'll do content extraction, we'll deal with images, we'll vectorize the content, everything you need to do so at retrieval time things work. Now, what we see a lot in practice is when you have an application that manages content internally, you usually land this content in some store, like either in blob storage or in a database or in OneLake if you're using Fabric. So we work very hard to make it easy to connect the search stack with all of these object stores without you having to deal with the mechanics of it. So when you point us at, say, any of these, blob storage, OneLake, and whatnot, we'll run a full ingestion pipeline, which we'll assemble by default. So if you don't want to think too much about it, just point us at it, and we'll do chunking, vectorization, all of that, and you'll get very high quality results. If you want the control, you can customize every step of it, inject your own custom steps and whatnot, so you can get exactly what you want out of it. And while these things tend to be text heavy, we'll also deal with multimedia as well. Now, when we're processing these things, first step is we look at a set of files. PDFs are a typical thing. And we have to understand what exactly is inside so we can present it to agents. So for that, we've integrated Foundry IQ with Azure Content Understanding, which gives you like high-end components for things like optical character recognition, document layout. A typical challenge is reading order is complicated, and you need to preserve it to understand the document. Dealing with tables is in the category of life is too short to kind of handle things like tables that span pages, sparse tables, all of these things. So through content understanding, what we get is high-quality extraction from the original content that then we can use to index and then feed the models. So let me show you a couple of these things in action. So I'll come back here. I'll go to the knowledge base I created before. And let's start by saying maybe my application uses blob storage to land content that is internally managed by the app itself. Maybe it's PDFs or markdown files or things like that. So I'm going to say I want to use blob storage. I have like a bunch of files with nodes. So I'm going to say nodes. I'm going to say annotations for movies. And I'm going to pick my storage account. It's called build26. Let's see if we find it. There we go. I'm going to pick my container. I'm going to say I'm going to use system identity. And for content extraction, I'm going to say standard, which means use the full content understanding capability. There is an embedding model already set, so that we'll do vectorization with that. And if you want, you can give us a chat completion model too, and that will enable us to do image verbalization to handle media as well. So I'm going to just kick this off. And once this process runs, so it'll run in the background, and it's not a one-shot thing. It will import everything now, but it'll also make it so it runs continuously, and it tracks changes, and when things change in the source, we'll incrementally feed the changes into a search index. So you automatically have a search index that is always fresh, and the Foundry IQ can use for grounding. And now I have multiple knowledge sources here, which means the agentic routing system can make choices about when to use what, and that's what descriptions are for, among other things. So just to give you a quick example, since I'm here, let me show you a couple of examples of content understanding. So typical things you need to deal with is, one is a lot of PDFs actually have pictures inside, like scans. And in this case, this is a table that is actually handwritten and whatnot. And you can see that the markdown file has even extracted not just the tables, but even the checkboxes. And if you have a business-looking document like that, we'll understand the layout, we'll catch the reading order, that there is 2 columns, we'll extract the pictures and whatnot. And sometimes you have more structured content. And what you can do is you can give us a schema of what elements of the document you want us to extract, and we'll isolate that and extract it so you can feed it to the agent or use it as filters and things like that. The other place where your data may be is, so far we talked about data inside the application. And a lot of what we see in use of Foundry IQ is you have your application, you have your own data, and you want to power agents with that. Now, that data rarely lives in isolation. If you think about the data in your organization, there's probably a bunch of Word documents and all of your calendar and email and whatnot. It's all sitting in your M365 tenant. And we have Work IQ that enables direct access to that. We also have in Fabric all your analytics state. So all your data lake, your data warehouses, and you can build data agents and whatnot on top. And the Fabric IQ layer allows agents to communicate with all that information, and it'll handle things like natural language to SQL and navigating multiple data sources and whatnot. And then finally, to access the web, we have Web IQ that we just announced yesterday. Now, we built each of these IQ components so that they work fine in isolation. And if your data is in one of these places, please don't complicate things. Just use the one that you need, and you'll be all set. Now, it's very common to have an agent that has to deal with your own application data and then maybe interact with your M365 content or your analytics structured data. And we want to make it easy for you to connect all these dots. So Foundry IQ out of the box supports integrating and connecting to the entire spectrum of the IQ platform. I'll show you a little bit more in a second. Now, before I go there, the last bit of kinds of data we can connect to is the thing you use when the built-in options don't do it for you. So if you have data in one of our supported knowledge sources, just point us at it and we'll deal with everything. Now, sometimes what you have is not just data. You have an application that you want us to connect to and treat as data. So we debated about what is the right interface for this. I kind of wish there was like a ODBC for agents or something, but there's no such a thing. And the thing about MCP is that it's universal. Like, it's not exactly meant for data integration, but it's everywhere. And if you don't have an MCP server, it's easy to make one. So it became a great integration point. What we'll do is we'll turn the MCP output through heuristics into like an item-oriented list of things if we can. And then we'll even run our own ranking system on top to improve the relevance of results, even at MCP. This means you can bring any data source, either of your own application, or I've seen things like, for example, using the GitHub MCP server to turn issues into one of the tables that you feed into the system, and it kind of just works. So let me show you a couple of examples of this. So first, I'm going to go back to the same knowledge base. So I'll start with Work IQ. The interesting thing about Work IQ is because you just need to point us at your tenant, there is actually nothing to configure. You just tell us that you want us to integrate with Work IQ. Now, your tenant admin has to give consent because, of course, this is your office data. You have to allow us to access it. But once we have that, then it'll just work. Now, for Fabric, the interesting thing about Fabric is that Fabric has all sorts of things in it. Like, it starts with a one lake at the bottom where you can have all your both structured files like Parquet and things like that, and unstructured content. And then you can have on top of that semantic models and Power BI reports and whatnot. And then you can build data agents and even ontologies on top of that. So what we did in terms of integration is we actually integrated with the entire OneLake catalog. So you can see here that when I say Fabric IQ, I see all sorts of objects here. Like I see lake houses, I see data agents, ontologies, and whatnot. So I'm going to give this a name. I'm going to say movie stats. I'm going to say use for ratings and other stats. And if I go real quick to my Fabric instance, make this a little bigger, you can see that I have in one of my lake houses, what I have is a few Parquet files that just represent statistics about movies, like ratings and things like that. So what I did is I created a very simple data agent that works on that structured data. So I just told it what files to what Parquet files to use, and now I can ask questions in natural language, which Fabric will turn into SQL as needed and run all these questions. Now, if I only needed this, I can ask the questions right here. But if I'm building a knowledge base that combines the unstructured content from one place with the structured content from here. I want them to work together. So what I'll do here is I can just choose data agent. And in some cases, if I choose a lakehouse, for example, I'll get indexing options because we'll go index that data. In the case of in the case of this agent, there is really nothing to index because we'll kind of integrate the questions at retrieval time. So I'll just say create. And now I have like another knowledge source, except this knowledge source will send will talk agent to agent to the data agent and then retrieve the contents and then integrate into the rest of the retrieval workflow. All right, so let's add one more piece to this knowledge base. We talked about extensibility and we talked about WebIQ. Let me actually put these two things together. So what I'll do is I'm going to use, instead of one of these data sources, I'm going to go to browse for more. You can see that we have more things that we support. And I'll say I want to use an MCP server. And I'm going to call this MCP server WebIQ, maybe WebIQ2, because I already have a WebIQ used for web search. And then what I need here is my endpoint into WebIQ, which I have here. When you sign up for the WebIQ preview, you'll get this information. And then I need to authenticate, which I'll do here. And last, I need to say which tool I'm going to use, which I'll use web search. So now I have, so now I have a single knowledge base that can answer questions just like I used before. In fact, the agent that consumes it doesn't need to know that I added all these moving parts. Except now, this will use my content in Wikipedia articles when I need that. It'll use the web when it needs this, and it'll use Fabric data agents when it needs that. And the agentic orchestration will kind of make the choices about what to use when. Go back to slides. So one of the things that was interesting in the early days of kind of RAG, when we all realized you can build these kind of chat with your documents applications, is I think as an industry, there was a lot of novelty and desire to understand how that works. So we took all of our documents, put them in this thing, put a chat interface on top, and we're like, here, like we can do this now. Now, here's the thing. In real world, if you look at the documents in your company, it's not like everybody can see every document. So this is, document level security is not the kind of thing you just want to improvise real quick while you're building the rest of the stack. So it's important that the actual retrieval system supports the same security model that the underlying data supports. So in Foundry IQ, we support propagating all the access control information from sources that support access control, like say SharePoint or blob storage with the hierarchical namespaces on where you can put access control lists. And we'll propagate that into the indexes we build under the covers. And this is integrated with Entra, so things like group membership works and all the things you would expect. So at query time, you just present the credentials of the user that is using, so it's just the kind of the delegated token of the user that is calling. And based on that, it would look like the thing you're searching only has the subset of items that that person can see. So security is enforced at the bottom of the stack. You don't have to layer your own on top. And actually, same with Purview. So if your documents have document sensitivity labels, those are encrypted. You can't just index them like with a random tool. But we support integration with Purview, so we will decrypt them, index them, and then secure them with the original access control information so that you can first control who can see them, and second, you can propagate the sensitivity labels to the UI that you are building. So that your application will look like Office from the perspective of propagating labels and whatnot. And we shipped a complete example for this. There's a URL there in case you want to put kind of all these moving parts together. Now, so first of all, let's go back to our agent, which should be done. So remember, we kicked off that at the beginning. I forgot to come back. So we can see that what ended up happening is this agent was like, yeah, got it. I need to go provision a service. It went, created a new Foundry IQ service, picked some name, gave it an endpoint, created an index, and added a few files. And we can actually go check. So if I go here, I'm going to use the Azure portal for this. I'm going to make it a little bigger. So let's find this resource group where we're creating things. And the name of the service is FIQ IMDb something something. This is this one. And we can see that it created a serverless service. It created an index inside the service. There is 100 documents there. And actually, we can go inside and pick at the content and see it actually kind of got all the movie information in here. So this was a one-liner that I told the agent, and I have a working index as a result. So we expect, in addition to developer workflows and whatnot, we expect these serverless Foundry IQ instances to be great for agents that want to create their own things on the fly and delete them later, create new ones, and so on. All right, so we talked about creating an instance of Foundry IQ. Then we talked about putting data in it. Now let's talk about retrieval. So retrieval is the moment that all the work that you do actually delivers value. In the end, when it comes to retrieval or search engines, the thing is useful the moment your top 3 or 4 results are what the agent needed to ground the answer they're looking for. So in Foundry IQ, we have an agentic retrieval pipeline that is built into the system that you can choose to use. Remember the layers of the system. If you just want raw indexes, you can use them. But if you want a fully featured retrieval pipeline that uses kind of an agentic method for retrieval, it's built into the system. Now, the agentic retrieval pipeline, what it'll do is it'll take the question or kind of data requirement from the agent that is calling it, and first thing it'll do is it'll do query planning, where it'll look at what data sources should it go look at and how the query should be decomposed into parts and then go search. It'll run a few searches and then come back, look at the results, and decide if it got what it was hoping to get. And if not, depending on the retrieval effort you configured, it'll kind of iterate and they'll search again based on the new information and then produce a final result to show to the agent. Now, this is something that we've been working on for a while. And at this point, we are in kind of the second generation of agentic retrieval. One of the interesting things we saw is, it's interesting how from about, say, October of last year to now, the models have changed significantly, including how good they are at things like tool calling loops and things like that. So we significantly revamped the agentic retrieval stack to take advantage of the latest that the language models can do. So you can see in the charts like improvements across the board. So just to give you a kind of a little bit of orientation of what these charts say is this is a comparison of multiple metrics. In this case, how good these systems are at recall, how often the answer is correct, how often the answer is complete, and also how often the model says that it doesn't know the answer even though the answer was present in the underlying data set. And we compare this against just lexical indexes, BM25 indexes, against hybrid search, so vector plus lexical systems, and also against knowledge base with the agentic retrieval off. We call it minimal mode. So you can see material improvements across the entire set of metrics for all of them. Of course, this comes as a trade-off, and the trade-off is latency. So if you use a search index, those things are so fast that you just don't need to account for it in your latency budget. They are instantaneous. Now, when you call agentic retrieval, that could be a few seconds or sometimes maybe 10 seconds or something like that if you have to iterate multiple times before we get to an answer. Now, where do these improvements compared to last iterations come from? Well, it's a mix of things. So first, as I said before, the language models got better. So our workflow for retrieval, we had to kind of update significantly to fit the style of the models that do really well today, and that made a huge difference. Second, we trained a new semantic ranker. We've been training re-rankers for a while, and we keep being able to push the boundary on that. Then we worked on answer synthesis. We have significant improvements there. And then for some tasks, like for example, MCP parameter binding, we did a lot of work to tune, depending on the model you're using, we do model-specific prompts to get it exactly right for that model, because there is enough variability between them. So the science team behind this publishes very detailed write-ups on this. If you're into information retrieval or you want to understand how we evaluate how these systems are working, I recommend checking out that URL where you'll see a lot longer of a write-up, including some of this data you see on the screen and a lot more. Now, in addition to that, token efficiency these days is a thing like that we all kind of think about. The other thing that we looked at is, in terms of what it takes to get a right answer, not what it takes to do a search. Like anybody can do a search with just a few tokens. The question is, did you get it right? So what you see here is kind of like a Pareto line of what is the best you can do with the fewest possible tokens. And again, we compare against ourselves, like we compare what is just hybrid search versus using full agentic retrieval, where you need an outer agent to orchestrate more, or we do the orchestration. And you can see first that we need fewer tokens to produce better answers. And second, which is not necessarily part of this chart, we've worked a lot in making sure that the way we construct prompts, like the way we manage our own context, is aware of how token caching works to make sure that first it's faster because you hit the prefix cache on the language model you're hitting, and second, it's cheaper because cache tokens are always cheaper than the running full-on tokens. So to give you a sense of kind of how all of this can be put together, so what I did is I just crafted a quick, crafted as in vibe. I used to say I wrote, as in I wrote the code. I don't know what to say these days, but I have a thing that what it does is it just calls the retrieve API for the knowledge base we just created, and it'll show us a little bit of the internals. So I'm going to ask it to run in medium, so it'll run a little longer. And I have a quick prompt that I want to give it. I'm going to ask to go do this. So now that we have a set of moving parts in that knowledge base, I want to go use that knowledge base to go perform a number of tasks. Oh, I forgot to show you this. So now that I have multiple data sources, and some of them are actually online data sources, we can't just create a knowledge base without telling us which model we use for the actual orchestration, which is what I forgot before. So what I'll do here is I'll say, use GPT-454 mini. I'm going to choose a default reasoning effort. You can override it later. And I can also choose whether I want answer synthesis or not. And I can optionally give steering instructions for both of these things. So now, with that in place, we're going to call retrieve again. So this will take a second to run. But once it runs, I ran it a little bit before. So let me show you the output. So in this case, you can see, it went to the ratings part. The ratings are they are this data agent that is running in Fabric, querying these BRK files in SQL. So you can see the results from that. And then part of the question is, how did they do in the box office, which is in none of my data sets. So what it did is just use the web grounding part, went to the web, grabbed the movies that were in the top 10. I'll leave you to decide whether or not those are the actual best 3 sci-fi movies. And then he pulled the results, and it gave us an answer on some of them. And some of them, he was like, yeah, this was not on the web, who knows why. But we got a very comprehensive answer. And you can see the activity here where, the planner ran. Then first he went to the data agent. I assume he went there to find what are the top sci-fi movies. And then he hit the MCP server for web, discarded some of the content, did a synthesis step where he constructed an answer, and then finished the reasoning process with that. And along with this, I have all the references where in each one of them you can see where this data came from, what is the kind of knowledge source, and when the knowledge source gives us information, maybe a link to the underlying file and whatnot, we'll present it here as well. So all this information, usually you won't present in the UX, but it's great if you want to feed it to an agent to understand the dynamic, the interaction better, or you can use it for debugging as well. Go back here. And the interesting thing is all the technology and all the science that I talked about for improving ranking and relevance and agentic retrieval is behind that one API, either behind that one MCP server call or behind the retrieve call. And everything else will happen under the covers. Now, that said, a little bit coming back to the beginning, I said we designed the system to be cleanly stacked in a way that allows you to decide what layer of the system to use at what point in time. One of the design tricks that was non-trivial to pull off was to make sure that even when you pick a layer, even though you can pick layers, once you pick one, you don't want to be stuck in it. You want to have the versatility to go up and down the stack. And that's what we've done with the Foundry IQ stack, where you can do Foundry integration first, or you can do knowledge bases, or you can go straight to the core retrieval engine that we built around, like this is on Azure AI Search. And you can go up and down the stack as you need, or you can change your mind once you build one. And I wanted to show you a few examples of that. So remember that we built this knowledge base here. This is the kind of funky name that we got. And then we built some knowledge sources that are remote and some knowledge sources that have indexed content. So let's actually peek into what's happening under the covers. So I'm going to just go to Azure, in the Azure portal. And let me switch back to the resource group that has a particular service. And remember, this service was called Demo3. And first, I can find the knowledge base we created there, right here in the Azure Search Blade. So this is the one we just used. We can see all the knowledge sources. But if I pick a little more, remember, 2 of them were actually indexed content. So I can see the actual indexer. This is the job that does all the transformation. It's effectively the data pipeline that pulls data into the index. I can look at the runs. I can kind of configure the internals and whatnot. And I can actually go in and look at the index. For example, this was this one was the index that we created when we got all the files with the articles. And if I want, I can look at the schema, where I can see what is the construction of the index. I can even pick at things like you may not care, and then we'll choose reasonable defaults. Or you may have very specific comparisons, like or opinions. Like, for example, here is like, what is the vector search compression options, where by default we do 8-bit quantization, but you may want a different quantization policy or a different kind of re-ranking policy or things like that. And you can control all this all the way to details like this. And you can also look at the actual data. Like, for example, here, if I pull the content of this index, I mean, I could also search. But you can see these are the content. This is the actual snippet that was a result of chunking. And I can see the actual vector here, which, of course, is not very useful to look at it. But this is the vector we use when we're computing kind of vector differences for vector search. Not only you have the control to do this, but this also allows you to make choices about things like latency trade-offs, where you can do full agentic retrieval. And it'll take a few seconds, but it'll give you great results. And maybe in other cases, you are like, well, I want to do something like sort of what you do with files, where you just issue a whole bunch of searches, and you want real quick results so you can iterate on them. And that can happen really, really fast. I guess to give you like a last example of this, let me show you one last thing, which is just to give you a sense of the difference in speed of these things. So what I'll do is I have this other service where instead of those 3 or 5 files I showed you before, I took all of Wikipedia, in English Wikipedia, chunked it up, and put it in an index. So this has about 22 or so million chunks. So it's a sizable index at this point. And then I just wrote a simple client so we can kind of hit that endpoint. So if I search for simple things, we were talking about Neo before and Peel. Like you can see, this thing searches at the speed that I can type. In fact, I can't force the lag. Like I can say Microsoft build if I didn't have any typos. So this is searching on every keystroke, and I still can't keep up. So if you want an agent to say issue 10 searches or issue multiple rounds of 10, 20 searches each, all of them will finish well within the second, all together in parallel, which means you can completely change the way you think about retrieval. You can get us to run your agentic retrieval loop for you, or you can give the agent these entry points and let them hit the search index as hard as you want, and it'll be just fine. And even at tens or hundreds of millions of documents, like in the example here. So with that, this is all I wanted to share with you today. This is everything I showed you today you can use today. So you can go to Foundry or the Azure portal or get our SDKs and get going with this. And here's a bunch of other things that are going on at Build that are related to the topic I talked about. Hope this information was useful to you all, and thank you very much for coming here this morning.